Hey guys, so just a reminder, we have our next tests coming up and we're starting our last unit in the course. It's actually a small unit. It's not going to take us a huge amount of time to get through, but it is quite important once again for students going on to maths and various science type courses. I did hint on this a little bit in one of the earlier videos about scientific notation. And so that's one of the areas we're covering. And the other little area we're going to look at is involving, not revolving, but involving probability and what is probability. So we'll sort of see where we get to with these topics. I would say the scientific notation one is something that is really critical for anybody interested in going into any kind of science course. So we'll start with that first and see where we get to with it. So today's video is planning to be quite short, so I don't think it's going to take you a huge amount of time to watch this and digest it. Plus, I think some of it we've actually already covered in a previous video. So taking a look at our Math 9 topic, let's start our new unit, add section, and we'll go Unit 8. And let's call it right now Scientific Notation slash Probability. Might have been spelled right. And then we'll just do our tab here, and let's just talk about scientific notation. If you have a calculator handy, that would be really useful. If you have the school calculator, I will show you that one, although I think yours might be a slightly different color. I think they have a solid black model right now. So I'm going to unshare my screen just for a little bit here, and hopefully that makes things a bit bigger for you. So I'm not sure if that's in focus, kind of focus. So the button that we're going to be working with today is above the number 7. So there's 7. So above the number 7, you'll see the EXP button. The other button we might be using is the negative sign. So not the subtraction sign here, but the actual negative sign at the bottom by the decimal. So if I say -5, it means negative and then 5, not subtract 5. So once again, the EXP button for scientific notation and the negative sign for negative numbers. That makes sense? Hopefully that makes sense. Okay, so have that handy for yourself, and then we'll be talking about those buttons and how we make them work. Okay, how they work for us. So so let's take a look at just converting a number to scientific notation. Okay, so let's take a number like 5,000, and we're going to convert that to scientific notation. So let's take a look here. Turn that off, and so we'll take a number like 5,000. Ooh, that's a fancy color my daughter's chosen. 5,000, and let's turn that into scientific notation. So scientific notation is basically moving the decimal point in a number so that there is one number to the left of the decimal. So for example, the decimal point in this question, or this number, although we don't write it, it's assumed to be right there. So that's where that decimal point would be. And so what we want to do is we want to move it over so there is only one number to the left of the decimal. So I need to move it over once, twice, 3 times. So I kind of want the decimal to be there. So what I have to do is write this as 5 point, and then the rest of the number here. So I guess, I mean, if I move the decimal over and didn't get rid of the zeros, it'd be like 5.000 like that. Okay, but of course this would be like saying 5,000 equals 5. And we know that's not true, right? So I'd have to say something else about this number here. So if we look at what 5,000 is, let's do sort of a breakdown of this number here. So 5,000 is really 5 multiplied by 1,000. Okay, so 5 multiplied by 1,000. And now if you look at the 5 I've written, the decimal point is actually right there. It's actually it's like right beside the 5 now. So 5 multiplied by 1,000 is 5,000. So we could write this as 5 multiplied by 10 to the power of 3. And that's because 10 times 10 times 10 is 1,000. So 5,000 equals 5.00, times 10 to the 3, or just 5 times 10 to the 3. So let's take a look at another number, maybe not with so many zeros. This might make it a bit more, so I'll show you why it's a bit more tricky here. So let's say a number like 215, okay? And we said, well, let's write that in scientific notation, okay? So once again, the decimal point's not written in normally when we write numbers like that. We have to kind of remember where it would be, and that would be right after the 5. So there would be a decimal point right after that 5. So I need to move it over 2 units. So I have to go 2.15, and I'm going to multiply it by 10. But how many decimal places did I move it over by? Well, I could write this as 21.5 times 10, right? So 21.5 times 10 would be 215. Or if I moved it another one, I could write this as 2.15 times 10 times another 10. So I could just sort of think about, well, every time I move the decimal, I'm basically multiplying by a 10 here if I move it to the left. So really this would be 10 to the power of 2. So try this next question. What do you think this would be? 51,320. So turn that to scientific notation. Okay, well, let's first of all put the decimal where it's supposed to be. So the decimal needs to fall right after the 5. So there's going to be 5.132. Okay, now you could put a 0 on the end of that. That's not wrong, but technically you might think, well, couldn't I just put a bunch of zeros on the end of that? So it's up to you what you want to do if it's a 0, but I wouldn't mark you wrong if you threw the 0 in. I mean, it might help if you're new at this to put the 0 in, and I'll show you why it might make sense to you to do that. I'll put that 0 in. Is what you want to try to remember is how many decimal places did you actually move, because that's the number of 10s you have to multiply by. So I'm going to write times 10. But I need to know what power is going to go up on that 10 now. And of course, if you didn't write the 0 in, you might miss this. So right now the decimal is here, and I need to move it 1, 2, 3, 4 units over. So I'd have to times it by 4 10s in order to do that. So times 10 to the 4 here. Now, one thing you could do on your calculator is you could check this now to see if you're right. So let's see if this works here. So let's take 5.1320 and times it by 10 to the 4. Now, once again, you could type it in literally like that, like use the multiplication sign. But why don't you try this? See what happens on your calculator. I'm just going to do this on mine. 5.132. So 5.132 is what I typed in. And then I typed in EXP. So that's the button above the number 7. And then I typed in 4 because it's the power of 4. See? So 5.132 EXP. So it means times 10 to the power. And then I type in 4. And you'll see that gives you 51,320. So this button here means times 10. And then the 4 is the power on the 10, or really how many 10s you're multiplying by. So that's how we convert a big number into scientific notation. But what about a small number? What if you had a number like 0.00237 or something like that? Well, now what I need to do is move the decimal in the other direction. And I still want to have only one number to the left of the decimal point. So I need to really have 2 and then a decimal, because this has one number to the left, and then a 3 and a 7. Okay. Now, when I multiply by 10s here, multiply by 10s in the other example, it moved the decimal to the left. So when you multiply by 10, it moves it to the left. So if you're trying to move it to the right, well, now you have to undo multiplication, which means you're actually dividing. And to show you this, we could do it a couple different ways, but let's just write times 10. And I'm gonna put a red kind of circle here. And that means I still have to put a power in there. I'm not going to put the power in yet. But let's do a quick bit of review of fraction math here, okay? So for example, if you do let's say you said 0.3. Well, that's really 3 over 10. And if you said 0.007, that's really 7 over 1, 2, 3. So 7 over 1,000 is that number. And you can use your calculator to check that, okay? But what I want to look at is this statement here. Let's just take this. 3 over 10 is really 3 divided by 10, right? And when you think of that, that's just 10 to the first power, of course. So this would really be 3 multiplied by the reciprocal of 10, which is 1 over 10. And that actually is 3 multiplied by 10 to the negative 1. So it's actually a negative power here, because you'd actually be dividing by 10 to do that. Now for the 7 one, this one here, this actually would be 7 multiplied by, let's do the division first. Let's keep the same pattern I just did there. So we'll take 7 and we're dividing it by 1,000, right? And of course, that's the same as 7 multiplied by 1 over 1,000. And that's really the same as 7 multiplied by 1 over 10 to the 3, because 10 to the 3 is 1,000. And that is equal to 7 multiplied by 10 to the negative 3. So that actually is what happens when you are changing a small number into a scientific notation. So number less than 1 here. So now could we do that maybe in a faster way that's not as maybe complicated looking? That looks pretty complicated to me in terms of if you had to do that every question. So let's take a look here. So let's go back to here, okay? Now notice in the 10 to the minus 1 right here, that one right there, notice that you would have had to move the decimal 1 unit over to give you 3. But what about this number? What about this number here? Well, if I move the decimal over so that the 7 is to the left of it, I would have to move it over 1, 2, 3. And if you notice, it's negative 3. So maybe there's a faster way to do this. Doesn't show the logic like in terms of why it works, but a faster way maybe would be to say, well, if I'm turning 0.00237 into 2.37, first of all, I know I'm moving the decimal to the right, so I'm really dividing by 10 or multiplying by the reciprocal, which means this is going to be a negative power up here. And how many decimal places did I move it? Well, I moved it 1, 2, 3. So minus 3. And once again, let's check your calculator now. Let's see if this works for us. 2.37 exp. And now you have to use the negative sign 3, not the subtraction sign. So 2.37 exp negative 3. And that gives me 0.00237. So I'm going to write just a few more numbers here, and I want you to try to convert them into scientific notation here. So example, 0.055, example 1237700, and the last one, let's do 0.0005701. There we go. So maybe just pause the video and see if you can do that on your own. Okay, so first one, I am moving the decimal 2 units to the right, so I'm going to have to use a negative power here, and it's going to give me 5.5 if I do that, multiplied by 10. And then how many times did I divide by 10 here? Well, I moved the decimal 2 places over, so negative 2. Okay. Next question, I move the decimal so that I write 1.237 multiplied by, well, how many places did I move the decimal? Well, I actually moved it to the left by 1, 2, 3, 4, 5. So really to the 5 here. And notice it's positive because you moved it to the left. Last question, I'm moving to the right, so I'm going to have a negative power. So let's write the number first of all. So write the number and then the decimal. So the first number and then the decimal, and then 701. Okay, so notice I'm just looking at that part right there. and then multiply by 10. And then count how many decimal places you moved it. 1, 2, 3, 4, 5. Now it's to the right, so I'm really dividing by 10 5 times. So negative 5 in that case. Okay, so that could be tricky if you've never done that before. So let's just write a few quick rules on that. So if we move the decimal, to the left, we have a positive exponent. And if we move the decimal to the right, we have a negative exponent. And basically, to go to scientific notation, you have to move the decimal so there is one digit to the left of the decimal. So it's really important, right, to make sure you're moving it the right way and putting it in the right spot. So let's take a look at a reverse question then. Okay, so let's say you were told, this is a fancy color. Let's say you were told you had the number 3.25 multiplied by 10 to the 6, say. Okay, and someone asked you, could you write that in a non-scientific way, so not in scientific notation? And so once again, you'd have to figure out which way to move the decimal here, okay? So this all comes down to our first two statements here about negative and positive exponents. So 6 is a positive exponent. So I need to be moving the decimal to, sorry, I would have moved the decimal to the left here, okay? So basically I'm multiplying by 10 6 times, okay? So these rules, I'm just gonna write a title here. These rules were for converting a number to scientific notation. Okay, so you got to make sure you know which way you're going here on this. So if you convert to scientific notation, then you would follow the rules that I've kind of listed here. So rule 1 and rule 2. Okay. But if you're going the other way, if you're actually converting from scientific notation to the normal way of writing the number, so a more conventional way of writing the number, then you actually have to reverse these rules. And I'll show you why in an easier question here, okay? So let's say you had a number like 5 times 10 to the 2, okay? We really know that's 5 multiplied by 100, which equals 500. So in this number here, we're actually timesing 3.25 by 10, 10, 10, 10, 10, 10. So we're timesing it by 10 6 times. So I need to maybe write this out and go 3, and then I go 1, 2. So that's 1, 2. And then I would need to go 4 more places. So 4 more zeros. 1, 2, 3, 4. Okay. So let's just check that. So if I move the decimal back, it would be 1, 2, 3, 4, 5, 6. So that's kind of tricky, I think, if you're going the other way. So if you're if you use your calculator, you could see that, I guess. So you could say, well, 3.25 times exp times 10 to the 6. That is that number, yeah. So that's the number 3,250,000. Okay. So let's just try 2 more, and then we'll stop there for today. And I'll just give you a couple questions for classwork to work on. So let's take a look here. Just 2 more questions here. So example. Let's write 6.31 multiplied by 10 to the 11, or let's make it positive here, to the 11. And then the other example, let's make this 4 I should make it negative 4.2 multiplied by 10 to the negative 6. So negative 4.2 times 10 to the negative 6 here. Okay, so the first one I'm multiplying by a whole bunch of 10s. So that's going to make this number much, much bigger. So I'm going to try to count here. Normally I would look at this number and think I have to move the decimal 11 spaces. So let's try this here. 6.31. So I would have moved it 2 spaces there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you don't have to put commas in. They don't usually do that anymore, but I kind of like to do it just to sort of show the grouping here. So that's 3, that's 6. Sorry, did I make a mistake there? So that's so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, we need 11. Yeah, one more 0. So I goofed that up. So so I need to have 3, 6, 9, and then of course the decimal would be there. So that does seem right to me. So that's good. Okay, there we go. That was a 6 at the beginning. And for the next question here, we have negative 4.2. So we have a negative 4.2. But now we're dividing it by 10, but we're dividing by 6 tens. So we're going to have to move the decimal 6 places here. But now it moves the other way. It becomes even smaller. So I'm going to think, I move the 4. So let's think here. So negative 0. And then I have to write, let's think here. That's the tricky one. So let's think if I move that. So I'm going to go, let's just write 4.2 right now. So I'm going to move it 1. And then I have to go 2, 3, 4, 5, 6. Okay, so that would be, so let's just do that again. So 1, 2, 3, 4, 5, 6. So I have to have 5 zeros here. So 0.00000. 1, 2, 3, 4, 5, 4, 2. And once again, I could type it on my calculator, just double check, negative 4.2 times 10 to the minus 6. So negative 0.000. So we got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Okay, so scientific notation, it's a pretty big thing if you're going into sciences down the road, not so much in grade 9. We don't do a lot of questions with scientific notation. So this sort of area is where we sort of see it being introduced. But the further you go in math and science, you're going to see more and more of these types of problems. Okay, so I'll just stop there for now and give you a couple questions, not too many, just to kind of get you thinking about scientific notation. Don't forget your Friday or your test coming up on Friday.